Dump on this one. It's not too difficult to set up the two volumes, so that's the volume using the disk method. Um, rotate it around the y-axis. You have to use the inverse function, unfortunately. And then this is the volume of integration using the shell method, but radius and height, again, rotate around the y-axis. So that's fine. Set up the integrals for the volume using both methods, x and y-axis. Prove that both methods approximate the same volume, which is easier to apply. Well, I guess it depends on the function. I suppose this one, because you don't have to find an inverse, but you have to deal with the x multiplying it, so I don't know. More interesting to me, more difficult, is how to prove that these are actually the same. One problem to make the comparison difficult is the fact that they have different limits. So if I was to use the substitution, y equals f of x, then obviously that means dy would equal f derivative x dx. So I could change the volume for the disk one. That would be pi. And then that would be f of 0, which is b. And then no, hang on, sorry. Here y is 0. These are y's. So what value of x do I need to give me a 0 on the y? So yeah, no, that'd be 1 and 0, wouldn't it? Yeah. It's f of f of 1 is 0 and f of 0 is b. Okay. And then that would be f inverse f of x squared f derivative x dx. Now I need an x here, and an x is f inverse y. So like, might be good to split that square. So f inverse y, f inverse y, f derivative x dx. Okay. 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 Oh, well, they cancel actually. So that makes an x. And they cancel. So that makes an x. So then what you have is pi 1 to 0 x squared f derivative x dx. So I'm trying to get to this, and I'm getting closer. Except I'm annoyed that the limits are backwards. It makes me worried I made a mistake. Another substitution is in order. If I said u equals x squared f of x, then du dx would be 2x fx plus x squared f derivative of x. So x squared f derivative dx would be, okay, so this one could be changed into pi, 1 to 0, du dx minus 2x f of x dx. Okay. So if I apply the dx to this, it would cancel the dx, leaving me with integrating 1 du, which makes the u. So that would be pi u, which is x squared f of x 1 to 0. Put in 0, we get 0, and put in 1, we also get 0. Nice. So that's gone. Minus pi 1 to 0, 2x fx dx, and then the minus applied to the integral switches the limits, and we get pi 0 to 1, 2x f of x dx, which is the volume using the shell method. So I was able to start at the volume of the disk method and arrive at the volume using the shell method. So I've proven that these two integrals are actually compute to the same thing, or rather one could be simplified into the other. Yeah, a little bit tricky actually.